In this video, we're going to go over multi-step reactions. So we've covered a lot of reactions so far. We talked about a couple of reactions that you can do with alkanes, but then we also talked about a lot of reactions you can do with alkenes. And in this chapter, we've talked about reactions with alcohols. So oftentimes when chemists are trying to make a specific product, they have to start with something that might need multiple reactions in order to get to that final product. So that's where we get that multi-step reaction. So for example, let's say that a chemist has this alkene and they're trying to make a ketone. So they're trying to add this carbon double bonded to oxygen, but all they have available is that alkene at the start. So typically, what chemists will do is work backwards. So for example, we know that we can make a ketone. So we've got our carbon here and then two other carbon groups attached. We know that we can make a ketone from an alcohol. We just saw that in the previous lecture. But what kind of alcohol would we need? Would it be a primary, secondary, or tertiary alcohol? A secondary alcohol, right? So maybe to start, we would need this OH group attached to the ring. And then we could add an oxidizing agent, and that will give us our ketone. Plus some water, but water is pretty easy to remove once you've created it. You can just boil it off, or you might be able to just separate it from the ketone itself. So this would probably be our second or third step, let's say. But we need to figure out, okay, we're starting with an alkene. Is there any way to go from our alkene to this alcohol here? So is there any way to turn a double bond into an alcohol? Yes. So remember, previously we saw that if you have a double bond, you can add water across the double bond. And remember to add that catalyst, sulfuric acid. So that's going to add an OH group on one side of the double bond. And here it's symmetrical if we draw a line through it. So it doesn't really matter which side the OH group adds to. We don't have to think about Markovnikov's rule here. Okay, so now let's piece everything together. So we start with our alkene, and then we're going to add water across the double bond to get our alcohol. And this is a secondary alcohol because the carbon that's bonded to the OH group is bonded to two other carbon groups. Even though it's in a ring, it's still considered two groups. And then we're going to add an oxidizing agent to turn that alcohol into a ketone. Okay, so let's try a problem on our own. Let's see if we can figure out another multi-step reaction. Okay, so let's say you're starting again with an alkene. So I'm going to give you a different alkene here. And ultimately, we want to end up with a ketone. So see if you can figure out the different steps you would have to take to get from the alkene to the ketone. And it should be somewhat similar to what we just did. So feel free to pause the video. When you're done, you can unpause and we'll go over it together. Okay, so like we saw last time, to make a ketone, we're going to need a secondary alcohol, right? So let's just kind of work backwards. So we'll need a secondary, oh, whoops, don't know what happened there. Secondary alcohol. And to make a secondary alcohol, we could use our alkene. Okay, so we're just kind of going from our alkene to a secondary alcohol to the ketone. Okay, so let's break that up into separate steps. So how would we go from our alkene to a secondary alcohol? Well, as we saw before, we can add water and our catalyst, sulfuric acid, and that should add an alcohol group. But what side would the alcohol group add to on the double bond? So we've got two options. We've got the carbon with less hydrogens and the carbon with more hydrogens. So the hydrogen from our water molecule is going to add to the side with more hydrogens. So that means that the OH group that's left over will go to the side with less hydrogens. Great, so that gives us our secondary alcohol. So again, Markovnikov's rule tells us that the hydrogen always adds to the side with more hydrogens. So that means our OH group will add to the side with less hydrogens. Okay, so now we have our secondary alcohol. And we know that that will make a ketone. But what do we have to add in order to convert our alcohol into a ketone? An oxidizing agent. So we could add potassium dichromate or potassium permanganate. Or you could also just write an O in parentheses to indicate that you're oxidizing. All right, so this is a shorter video, but I did want to show you what chemists do on a daily basis if they're synthesizing something. They have to kind of think backwards. They have to start at what they want to make and kind of look at what they have available and try to come up with an efficient method to make that product. Okay, in the next video, we're going to go over some important alcohols and we'll kind of start to wrap up this chapter. So I will see you then.